engineering science. Me, Mr. Young, back again with heat energy this time, just looking at the formula and how to use it. You can see the heat energy formula here, HE this time for heat energy, measured in joules. We've got Cm delta T down below here. So C is your specific heat capacity. This is measured in joules per kilogram Kelvin. Kelvin's another form of way of measuring temperature. I wouldn't worry about this too much. You'll always be given the specific heat capacity. Basically refers to the object that you're looking to sort of measure the heat energy of. So if it's water, then water has a specific heat capacity, meaning that it'll take a certain amount of energy to heat it up by a degree. And obviously different objects will have these different specific heat capacities. So wood might take a bit longer or a bit more energy to heat up than, say, like oil or something else, okay? So specific heat capacity will be given to you, and it should also be in the data book, right? M is mass, is always in kilograms, and this triangle with a T, I'd mentioned it earlier, is delta T, and it means delta means change. In this instance, it means change in temperature in degrees Celsius, okay? So you're looking at the change in temperature. So if you've been given something that says, the initial temperature is 10 degrees and the final temperature is 20 degrees, it's then the change in that temperature, which is 10 degrees, okay? So we'll run through a couple of examples here just to show, but there's the formula there. Okay, so it's just similar to electrical energy with the three different ones down the bottom. So again, we've got an example here, calculating the heat energy of a kilogram of water. So it's starting off, the initial temperature is 30 degrees, it goes to boiling point at 100 degrees Celsius. So our change in temperature here will be 70. Okay, so you'll be taking that change, not one of the ones that's shown there, so 70 degrees, and we've been given the specific heat capacity. So we cover up HE, we see it's C times M times delta T, which is specific heat capacity times mass times change in temperature. So you'll be given this, so you'll write that down obviously, and that's fairly easy to work out. You end up with that value, and you can change that into kilojoules, at 292.6. So fairly straightforward. If we want to find out the mass, here we go with the mass, similar figures, but we've got 200 megajoules here at the end here, and we've got the specific heat capacity of water is the same. So this time, if we cover up mass, it's going to be heat energy divided by the C value, specific heat capacity, which I'm going to have to stop saying because it takes ages, times your change in temperature. So you'll end up with that. So the wee star here just means multiplying. So heat energy divided by C multiplied by change in temperature. So 200 megajoules times divided by that. So work out the bottom value first, which you find it be the same as before. So 200 megajoules divided by the 292,600, and you'll find it's quite a big number. This should have maybe made the energy slightly less, but 683 kilograms. You'll find that answer becomes okay. So again, fairly straightforward. If you've done enough of these in the previous units with other energies, you'll find this fairly straightforward by now. And again, what might happen here, for example 3, is calculate, doesn't say the change in temperature, I've put it as calculate the final temperature. Okay, so you've been given the mass, you've been given the initial temperature, and we'll be given, again, our energy and our specific heat capacity. I've just kept them all the same as water because it's most likely the one you'll be given in an exam. So let's change in temperature. I'm going to cover that up. So our formula will be heat energy divided by C multiplied by M. Okay, and then we've been given that. So 150 divided by that. And you'll find it turns out to be, like that, again working at our bottom value, turns out to be 3.6 degrees Celsius. Now, just beware at this point, you're not done, because this is delta T, this is the change in temperature. This is how much it's changed by, it's not the final temperature. To get the final temperature, you're going to have to add your initial temperature and the one you've just found out to find your final temperature. So be wary of that. They might give you this as a wee kind of stumbling block, see how you can figure out the last bit. And it's important that you manage just to look at that. Sometimes it might just say work out the change in temperature, and that's fine. But if it says final temperature, you need to be able to work out the way of working it out, like below. They might even give you the not give you the initial temperature, and they might give you a final temperature and get you to work back and find the initial temperature. And you'll be able to do that by taking your change in temperature and minus the final temperature. So you just have to be wary when you look at the question for that one. So just to recap at the end here, your C value, specific heat capacity, hopefully that's the last time I'm going to have to say that. It varies for different objects. Most likely be given water, but if it's oil, you'll be given the C value for that. Okay, and it'll always be given to you. I've just mentioned that. And it's also in the data book. Your triangle T is your change in temperature, hence the reason I made the T capital and not lowercase in case you get confused with time. This is a change in temperature, so just be wary of that. And the question at the end, if you're looking to find out a temperature question, they might ask you for the final temperature and not the change in temperature. So you just have to be aware that that is the case, okay? So thanks for watching, and as always, stay safe, folks.